Did you have a lot of people over the last 4 decades wanting to acquire your company?
Well, let's see. I started in October 1980. I think I got my first offer. It might have still been in 1980, but at worst, it was the first few months of 1981. And almost on a routine basis from then on.
This is very exciting. Hi, I'm Dale Peterson, and welcome to the Unsolicited Response Show. I'm very pleased today that our guest is Dr. J. Patrick Kennedy. He attended the University of Kansas, where he earned a Bachelor of Science degree in Chemical Engineering and followed that up with a PhD degree in Chemical Engineering. Pat became a registered professional engineer in Control Systems Engineering. He worked as a research engineer for the Shell Development Company and as an application consultant for the Taylor Instrument Company. Where things started to get exciting were in 1980 when he founded the Oil Systems Inc. company, notice OSI, which later changed its name to OSIsoft. And most of you know that as the people behind the PI system. He led the company for over 40 years until it was sold earlier this year to AVEVA for $5 billion. That's billion with a B. And now Dr. Kennedy holds the position of Chairman Emeritus at AVEVA. So, Pat, welcome to the Unsolicited Response Show.
Thank you.
You know, congratulations to yourself and the whole team there at OSIsoft. Not only the people there now, but the people that have been there decades ago. You really achieved a dominant market position that led to that $5 billion sale. And we're going to talk a little bit more about that, but I actually want to begin at the beginning. So you started the company in 1980, again, Oil Systems Inc. And if I believe the internet, it was a process controls consulting company designed to help oil refineries. And then in the mid-'80s, you created this process database leveraging a new sampling algorithm as a project for an asset owner. Now, I must say that sounds very familiar to like Eddie Habibi's story at PAS. Where he started, worked for a large oil company, went into consulting and projects, and then developed a product. I'm a little curious, when you developed this first product that was called the Plant Information System, now called PI, how did you convert, or what were your thoughts when you were moving from consulting to a product company? Was that something that took a while? Was it a difficult decision? How did you make that conversion?
Well, it wasn't that difficult for us. We actually didn't build the system for a user. When you are doing advanced controls, one of the established procedures is that you have to ensure that the controls don't behave pathologically during nonlinear events. Mm-hmm. And the way you do that is that you put them in, and then you go away and leave them alone, because you certainly can't cause large nonlinear events. The operators won't let you. But if you go away and just leave something alone, sooner or later there's a storm or something breaks, and you get to observe how your controls operate during those periods. But what we found is that the amount of data available to operations, which is where we were, was really minimal. And so we built the system as a data logger for ourselves. At the same time, I knew the people at DuPont that had developed these algorithms for storing data. They're universally called compression algorithms, but they're really not compression algorithms. What they are, they're algorithms that tell you how often to sample a point based on keeping all the information in the point. So something that's dead level, it doesn't get sampled very much. Something that bounces up and down, it might get sampled a lot more. But I encountered those methods in a DuPont system when I was with Taylor. Mm-hmm. And then during the initial years of OSI, I attended the ISA in Houston, where John Hale actually presented these methods and said, we would like to see everybody use those. So we took them and implemented them. And they turned out to be very, very useful, because they stored the data in its original fidelity, which is exactly what we needed for the task that we'd set out to do.
Now, from a technical standpoint, that makes a lot of sense. I'm a little bit curious, though. You're an engineer. You went through all the work of getting your doctorate, your PhD in chemical engineering. You've worked on projects. Then switching over to a product company where you have to start to worry about things like HR and finance and product marketing and all those things. How was that conversion back in, I guess you started the product in 85. How was that conversion? Did that happen quickly, easily, or was that something that was a challenge for you?
Well, certainly. Well, fortunately, it took so long that we were able to ease into it. We actually had our first, if you will, product in 1973, but it was developed on a Hewlett-Packard computer, and it was very specialized for refineries. We redid it on the VAX computer because that was becoming quite popular at the time. And then we actually showed it at the ISA in 1986.
Mm-hmm.
But even at the time we showed it, there were probably 5, 6 systems out. And so we were already sort of a product company. But at those times, we were a product company like, grow your own companies, become product companies. We were learning that we had to have support. We were learning that we had to have training. We were learning that we had to have all these other functionalities. And so we had lots of time to figure that out. And that was fortunate. And what really gave us the time is the unbelievable value of these data. These are data that were never looked at because you couldn't get to them. And so our customers and our users gave us time to figure out what we needed to do to make it robust.
Yeah, I want to put a pin in that value of data because I'm curious how that understanding and value of data was a major, almost like a step function back then. I'm wondering if we're nearing another step function now, but we'll cover that a little bit later. I looked, and it looked like in 1996, so about 10 years after the product had been out there, there were over 1,500 copies on servers, 20,000 copies on clients. I took a look at some of the interfaces, the way the data comes in and out of the Pi system. A lot of VAX on there, a lot of open VMS. It was a different time than what we live in today. What was the competition like those first 5 or 10 years? You have this new product. Were you seeing other people trying to do the same product? And if so, what kind of companies were those?
The competition, if you will, were people that would store data as part of a bigger project. They wanted to, for example, put in online models, or they wanted to do advanced process control, or they wanted to do MES. We were really one of the few companies that just specialized in getting and managing and maintaining the data. So there was competition, and some of it by giant companies that were multi-billion-dollar companies even at the time. But because we were so focused, we looked like a much larger company because basically that's all we did.
Mm-hmm. You probably had a lot more content around that and expertise around that. Was some of this competition, again, I didn't enter the field until about 2000. And at that point, I saw most of the large control system vendors had their own historians. And some of them would have a choice to make between installing their own historian or a Pi server. And many of them chose to do both, quite frankly. Were those large ICS vendors a lot of the competitors in the early days?
They were both competitors and partners. On some of the control systems, we actually supplied the historian feature for them. And they grew out of it. Maybe they built their own. Maybe they continued to use the Pi system. But what we found is that our forte was to move up a layer to where we were talking to multiple control systems, multiple sensors, multiple people were using us. In other words, we became almost a data broker, which is very difficult for somebody that makes a particular hardware product to do. And so that kept us focused for quite a few years on basically being the data infrastructure instead of trying to actually create a SCADA system or create a control system. The other thing is that, of course, we know how to build a SCADA system. Probably 50% of all the people at OSI came from SCADA companies, but we chose never to do that because it wasn't what we wanted to do. Our business plan was to basically grab the data that came from operations, do what operations needed to help them out, and then deliver that data up to the management and to the other divisions within the company. So being this thing in the middle has been our business plan for decades.
Well, that makes a lot of sense. And actually, that was one of my questions is the temptation must have been huge. You have this relationship with the customer, right? And many of them, probably not all of them, but many of them loving your product. In some cases, not liking their ICS vendor and saying, hey, Pat, could you just do this for us? Could you just do that for us? And I noticed a little bit in looking in the background that there was a plant suite. It wasn't your product, but kind of an integration of multiple products. Was there any time where you came close to expanding beyond this, let's say, this data broker niche that you had?
We continuously looked at the adjacencies, I guess they called them. And for various reasons, we would stay out of those businesses. Sometimes we actually entered partially in, found out the water was really cold, and then got back out. But yes, of course, we looked at things, everything from quality management to MES to all of these other uses of those data. And then what we determined is that we're just better at doing what we do and just doing it better and better. I've always said sometimes when companies look at where they want to develop, the companies that develop and try to invest where they're weak, their goal is to be average. Mm-hmm. So our goal was to be exceptional, and that meant staying with what we did and improving it as fast as we could.
Yeah, it's something that always impressed me as that's always been a challenge of mine, is to stay focused. I always want to jump to the next new thing. So I've always been tremendously impressed by OSIsoft doing that. I'm wondering a little bit too from, did you have, you're so ingrained now that it probably is an issue now, but in those early years, were some of the vendors, the large vendors, worried about OSIsoft competing with them? Like you were, in a sense, sometimes they would try to say, no, you can get our historian or you could buy OSIsoft. If you had developed an ICS system, were you at all concerned that then you might get more pushback from the larger vendors?
Oh, yes, of course. We stayed away from anything that looked like products that were used or built by the people we wanted to be partnered with. And that meant SCADA systems, PLCs, control systems. We tried to be as supportive as possible because our goal was to bring together all of the data that people need to make decisions. And one of the interesting things about the decision-based, database decisions is that the data you need is set by physics. So you can't say, well, I'm going to make decisions out of data from this particular piece of equipment, because it might not be all of the data you need for the decision. So our goal was always to be this infrastructure. We didn't call it infrastructure until later on, but I had to change the name because people would think of us as essentially a module that sat inside of a control system. And although we did supply systems that performed that function, our main goal was to supply essentially the plant information system, and then beyond that to the enterprise information system and beyond.
It's funny when you mention that. When I first ran into OSIsoft, I noticed that you had an interface for almost anything. You could get just almost any data into a Pi server, even though it was almost like an 80-20 rule, not quite that. A few of the interfaces were used most of the time, but there were one-off examples on even very obscure technologies and protocols. I hadn't thought about it, but when you were first starting the company, deciding to develop an interface every time someone asked you to bring into something into your product must have been a bit of a challenge. Did you just take that as a cost of doing business, or was the decision of which interfaces to do harder at the beginning?
Well, let me take you back to that era. When you look in the early 80s, there were entire companies that basically had only one interface. They would build themselves as augmentation to these new digital instrument systems, and they might have an interface, for example, to a Honeywell or a Foxborough, and they built their business around that. We chose a different path. I could see what was happening, that we needed to be more open, not necessarily open, but we had to get broader scope of data in order to solve the problems that needed to be solved. And so I made a decision back then that we would do any interface people wanted, as long as we could do it our way, and we would then maintain it and support it. And I gave them a fixed price of 10 grand. And we just did any interface people wanted. Now, my plan was that we'd do the major interfaces, and then after a year or so, things would quiet down and we could stop doing interfaces. That unfortunately did not work out. We still do probably a third of all development are interfaces. And a lot of this is driven by the fact that to do the applications we need, you need to interface. And I'll give an example of that. If you look at a power grid, we're all remembering the recent thing with ERCOT and other places where we've had disturbances on the power grid. If you wanted to look and be able to detect early or incipient failure of the power grid, you need to measure the waveform. 5-minute data doesn't do you any good at all if you're dealing with things that run at the speed of light. And the device that does that is called a synchronous phaser. So we had to interface to a synchronous phaser. And there's great stories of how that was valuable. If you look to the future, look at what's coming. Cameras. Have people thought about the data that's going to come out of those cameras? Imagine having one of these inexpensive cameras focused on every transformer you have. You get a marvelous amount of information out of them. But that means a lot of different interfaces. And so they just keep coming, and they're getting faster, and they're getting higher fidelity, and there's strange data that are coming from them. And our job is to grab that data and then make it available to whatever applications needed.
I want to pivot a little bit here to security, because this is primarily cybersecurity for ICS OT podcast. That's what most of our listeners are on, although I'm sure just about every one of them has run into Pi over the years. But I first actually saw you or met you back in 2006, and I don't think you probably remember this, but it was at a Process Control Systems Forum meeting, PCSF, which was the event DHS put on before ICS-JWG. Actually, I think it was the best thing that DHS has ever done in this space, really bringing the people together early on there. But I had an employee, Matt Franz, who had found some vulnerabilities in an ICCP server, and we were actually the first ones to publicly disclose vulnerabilities. And at this meeting, he gave a presentation, and then he got a lot of heat on, hey, you can't be disclosing vulnerabilities publicly. These are things that can never be disclosed. And I won't say that you yelled, but you forcefully told him, Matt, this is something you can never do again. So it was a really strong reaction against this. But the thing that surprised me, and I guess where my question is leading, is almost after that, after 2006, I saw OSIsoft really expend a lot of effort and attention to cybersecurity very early on. I mean, 2006, hardly anyone was doing anything. I know you had done some things before that, but I saw almost, again, one of these step functions where people got really serious, got involved with national labs. As the founder, CEO of OSIsoft, what was that shift in your mind that made you say, hey, this is something we need to start paying more attention to back around that time frame?
I don't know if it's so much a shift that is a subtleness, and that is when and how are these disclosed. So I totally endorse the idea today that people will find a vulnerability, and you go to the people that are responsible for that. And I don't care if they're competitors or if they're friends or whatever, you help them understand that there's a vulnerability out there and they need to fix it. I think right today, the disclosure to the public only comes after the vendors fix it or if the vendor refuses to fix it. And I believe it was more the process than anything else. Fortunately, in those days, the some of the hackers weren't all that skilled. The tools weren't available on the dark net, and the communication between hackers was not as sufficient to make it a real danger. In fact, I think one of the guys keeps saying that at the time we were security by obscurity. Nobody knew what a control system was, and so we ended up like that. But I believe that security is a big deal, and I think you could actually extrapolate that a little bit if I can diverge a bit, and that is I hear people saying we'll never go to the cloud because of security. Because what happens when you go to the cloud, of course, is the processing separated from the process by a network, which is another vulnerability. But I think if you looked at vulnerabilities and you looked at the problems, a lot of them come from the lack of maintenance, human errors, etc., things like that. So I believe the world will move to the cloud because of security. It's the only place where you can concentrate the focus and have the tools necessary to implement the kind of software you need to have something that's robust and secure.
Yeah, I didn't want to take us down the disclosure area, although I will say that we did end up disclosing that to the company LiveCert and via DHS. They just chose not to fix it. But what I was getting at more was sometime in OSIsoft's history, and I think it was somewhere around there, we started to see things like going to the national labs to get your products assessed, developing and seriously working a security development life cycle, which was very early on compared to your peers in the ICS community. I won't say you were the only one, but it was a handful of companies. Most of them were just saying, it's this private network. No one's ever going to get there. We don't have to worry about security. But OSIsoft really stepped it up early on. So I guess maybe to ask the question a different way is, what made you do that? Because I'm guessing it wasn't customer demand back then. Were you getting a lot of customer demand back in 2008, 2010, 2012 for security? And if you weren't, what drove you to do it from a company standpoint?
Well, I guess we have a singular focus, and that focus is to build up the value of obtaining this information for our users. And one thing about the value is that having basically vulnerabilities or bugs or doing the wrong thing, it's not so much they are a pain, but it's also lowers the value of the data. So you can't use a system, for example, for critical operations where you might put people or equipment in jeopardy if you build a system that is vulnerable to attack, and it might have those issues. And so we didn't really think of it as something separate. It's just something that had to be reconciled with the kind of work we were doing. A lot of the software, like you'll see in them talking about IoT and about other modern constructs in the digitization, they're discovering things like, oh my goodness, you send a signal out, it doesn't really respond the way it's supposed to. And this is just a learning curve that the SCADA control people had 30 years ago. And that is just trust nothing, but let's take whatever precautions we can in order to get the data more robust and more secure. And I don't really know if there was a pivot point or if it was a learning curve. It was just one of those things that became one of the good practices that you had. Like I would also just point out that although security is really important, if you look at the major failures of systems, a lot of them aren't really caused by security. They might be, or lack of security. Some of them might even be caused by security. For example, if you look at these keys that used to lock the consoles in an operator's environment, they never lock the console, because the most dangerous thing you could do with an operator would be to suddenly shut him off from the data that they need to see. So again, the real issue here is how do you make the data as valuable as you can, and handling the maintainability and handling the security are probably the two major parts of that. If you make a system hard to maintain, you will create vulnerabilities in a system that didn't need to have any. So we've worked a long time on this, and I guess one thing it makes it easier for us because we're so focused on the PI system. If we sold 50 different products in different industries, it would be much more difficult for us.
Yeah, that is definitely the case. We see that with a lot of vendors that are having to maintain systems that are 20, 30 years old and a few generations back across a wide product line. It's very difficult. I will tell you that we were really pleased that you didn't hold a grudge, because in 2008, 2 years after Matt Franz's thing, OSIsoft was, I think, the first sponsor of our S4 event. And you sponsored allowing us to, we did a hybrid event. We did a hybrid event back then. So we actually simulcasted over the internet way back in 2008. And OSIsoft has been a good help with research projects and a lot of things. So it's been a big addition to the security industry in our space, not just, for your own products. One question I like to steal from Tim Ferriss, the 4-hour guy, is, do you have a favorite failure? Is there something over the 40 years of building OSIsoft up that you tried, failed miserably, and you either learned something that was very important or prevented you from going down a path that would have been a disaster?
Oh, certainly. I used to say every mistake that can be made, we've made it. And that was actually supposed to be a positive statement, because we know how to get out of those mistakes. But probably the one I remember most is, and I don't know that it was totally our fault, but one of the biggest advances in how software ran was the ability to run scripts out into the operator interface or into various modules. And at the time, Microsoft was not going to license VBA. So we went in, and there were a couple of third parties, Mystic River, Summit, places like this, and we fully implemented scripting using the Summit scripting language. And this is very important. For example, if you want to embed an object in your screen, you have to have some tool to put it in there, and the scripting was the tool. And just as we were releasing that, Microsoft decided, well, we changed our mind. We're going to license VBA. And so we said, oh, and so we pulled everything. We stopped production. We took everything out and we redid it from scratch. The lesson learned there is that, again, if I'd had 50 products in 50 different countries, 50 different genealogies where they came from, then faced with a decision like that, it would have been very hard. But we're so focused on what we do, and we do not and never did do an inconsequential amount of software. We did a lot of software. We had more developers than nearly any companies in our space at the time. But we did get focused. And as we got focused, this just made the software excel. And we could handle things like, and you didn't say it exactly, but the implication is that one way to get old software out of the field is to build a better version and build it so it's easy for the user to update. And so that takes manpower too. And it takes manpower to basically look at the future. And it takes manpower to do all the things that you want to do in software. One thing to keep in mind, the PI system doesn't have multiple versions. The thing that would go into a pharmaceutical facility is the same thing that goes on a power grid, is the same thing that goes into a refinery. This is so critical to keeping the quality and support up that I don't really know how we would have survived if we'd had all these different versions that were customized for every industry.
Well, yes, I looked at the stats. You've got 38 of the 40 top oil and gas companies, all 10 of the top metals and mining companies, 37 out of 50 of world's largest chemical and petrochem, 9 out of 10 of the pharmaceuticals. So yeah, you're across just about every industry, and that doesn't even include water and a variety of others, water, transportation, all those others. You're mentioning Microsoft. One thing that I noticed early on was that OSIsoft got very deeply involved with Microsoft much sooner and to a much greater degree than most other companies in the ICS arena. I mean, everyone early on said, oh, we need to run on Microsoft, so we need to be on Windows 95 or Windows NT. But then there's the next step of actually saying, we're going to partner with Microsoft. We're going to work together to integrate our solutions tightly so that we can take advantage of all these things. Do you remember what led to that decision to do more than just deploy on the system, but to actually partner with them?
Well, I would say the primary focus was our customers, who have always been smarter and further ahead than we are. And you look at, take a simple thing like reporting. Sure, we can write report writers. There's some marvelous report writers out there. But if you look at simple tools like Excel, a spreadsheet, what's Microsoft done? Microsoft trained 750 million people on how to use Excel. And so this makes our job so much easier. We just have to support what's already there, and people are already trained. They know how to use it. And it's just been great. I think Microsoft has done a fantastic amount for this industry. And we saw very early on that people were going to be using their PCs to come through to talk to the system. They weren't going to use a dedicated terminal. And this then puts us into the Microsoft environment. And once you're in the environment, what you don't want to do, I think, is that you don't want to, for example, just run a window from your PC. You want it to interact with the PC and your Word documents and your Excels and get everything running. So we became very tight with Microsoft. And then you mentioned security. I recall one of the first security conferences I went to. It was at Microsoft, and they brought these people out of research who I don't think they'd ever been in front of a crowd before. So they just told us everything they were doing, and it was great. The thing I remember is that they said that Microsoft and the U.S. government were number one and number two, and we don't know who's number one and who's number two. And so we learned a tremendous amount about, computer capacity and multi-computers, how they operate together, networks. Until Microsoft came about, literally the only decent networking software out there was DECnet. And it was great. DECnet was far beyond its time, but the company didn't really have a good plan to survive. And so Microsoft stepped in and basically took over all of that. And it was a great partnership. And we've been partners with Microsoft for all those times. We're still partners with them. The Azure, we use Azure for the cloud. They've done a great job of moving into the cloud environment. They've done a great job of managing networks and we're very pleased with Microsoft as a partner.
I can now include in the show notes, but we actually have some really strong presentations from some of your technical team. I think it was as far back as 2014, 2015, how to actually use the Microsoft security. So not only how to deploy it on their system, but how to take advantage of all the things that platform offered. And it was, again, to a degree that we didn't see in many of your other competitors. Now, let's talk a little bit about acquisition here. So you did get acquired in 2021. I guess my first question is, going back to 2000 when I first encountered OSIsoft, the position you had there, I'm sure you had some people wanting to acquire you then. Did you have a lot of people over the last 4 decades wanting to acquire your company?
Well, let's see. I started in October 1980. I think I got my first offer. It might have still been in 1980, but at worst, it was the first few months of 1981. And almost on a routine basis from then on. And a lot of it was people wanted the software to put into a product. They wanted the software. They wanted one company actually wanted us to be their digital engineering force, which was a great move for them because that was way before people talked about digitization and digital transformation. This was back in the 90s. So it would have been great, but it wasn't great for us because our plan was to be this independent broker, and almost all of the offers would come from people that were pretty limited in focus. They either built an instrument system, or they built a SCADA system, or they built an ERP system or something like that. So yes, we've had lots of acquisition offers over the time. We actually started, the first was, I don't really know the times. I might mistake these, but maybe 6 or 8 years ago when Kleiner Perkins came in and convinced me that to be able to grow, we needed to be able to access capital. And I didn't really understand why at the time because we had plenty of money in the bank. But at the end of the day, they were very good for us. They introduced us to people in the world that we didn't know, and it helped us out. And then later, SoftBank and Mitsui came in, and then now AVEVA. So we sampled the water a little bit first, and then we started moving further and further toward acquisition. And then this year we actually did it.
Yeah. So that, I guess that was the logical next question is, why now? Why not 5 years ago or 5 years from now? Why today, or why 2021?
There's actually a pretty good answer to that. One of them is, if you look at the future, I think people have underestimated the size of future systems by orders with an S of magnitude. And I only bring to mind, think about a smart city. People talk about smart cities like it's easy to do. But now you have thousands of users all connected together. They're sharing a common sewer, common water, common power. And now we introduce electric cars, and we have to make everything run. And then people put solar on their roof, and then they put solar farms in. And then the battery guys come around. And now you have this whole thing working together. And it's way beyond the ability of people to keep it running and keep it running efficiently. So the systems out there are getting very, very large. And if not smart city, think about the grid. If not the grid, think about supply chain. So there are many of these systems out there. And I think one of the reasons that I thought now was a good time, one of them is that, I'm old. It's time for me to not work so hard. But there's good people in the company. Sure. We could have just gone on ahead like that. But handling these giant jobs where you're trying to control the shipping around the world, and you want to make sure that you keep things running and you keep track of how much temperature you've embedded in the food that you're carrying, and all those kinds of tasks, those are very, very large systems. And I felt that it was time to actually expand, not do anything different than we're doing today, but instead of thinking of a few million points, start thinking of trillions of points, because that's really what's coming. And so this was a good time.
Did you consider IPO at all?
I did. I looked at IPO, and I looked at public companies, and I've seen them for years. And what I've noticed on public companies is that one of the things that you have to always resist is this short-term focus, because every quarter everybody comes and looks to see what you've done, and they want you to change immediately, and etc. And I've always stayed away for ourselves for that, because that's such a different business model. Because I've always taken the approach that software is a very, very long-term strategy. If there's a new operating system, or if there's new technology out, or if there's a new wave coming, and you have to be able to see those waves and then act on them, it might take you 8 to 10 years to build a software package. And if you think about it, imagine a public company where you have to put your investors off 32 quarters in a row. That would be a very difficult thing to do. It's much easier to do if you're private. You totally believe in the future. We maintain our old customers. We keep everybody modern, but then we spend enough time and energy to make sure we're there when the future comes. So yeah, the IPO was problematic in that sense. I'm sure it was worth a lot more money. People would try to get me hooked on that. You can make a lot of money if you do an IPO, but really that wasn't our focus. I've always viewed that if you take care of your customers, the revenues are a result. They're never really a goal, which is, maybe it doesn't work, but it worked for us.
No, certainly did. Let's talk a little bit about the future. Now you've taken a step back. You're not CEO anymore. You're chairman emeritus of AVEVA now. But I'm curious, something you said earlier, and then the cloud, you actually mentioned cloud and security too. You mentioned that in the 80s, that there was a lot of data that wasn't being looked at, that wasn't being collected, and that there was tremendous value in that data if you could put it in the hands of the right engineers. Do you think, so it was, I call it a step function. We were here and it wasn't some gradual increase. As soon as they had access to that data, there could be some pretty substantial benefits to it. Do you see that the additional data points and the capabilities that the cloud and machine learning and other things are providing, do you see this as another step function, or do you see that as overhyped?
No, it's coming. It's coming hard. I heard once knowledge described as eating a big cookie. If you think of a big round cookie, the bigger the bite you take, the bigger the boundary. So the more data we have, the more data we need. So it just keeps on coming, and it comes in streams and rivers and whatever you want to call it. But there's a lot of data out there. And the information, one thing to keep in mind is that if you're looking at streaming data systems or real-time systems, whatever you want to call these things, it really isn't the number of points that you attain a limit on. It's the number of events per second coming up. Because if you're looking at systems that are basically putting out 1 million events per second, you can imagine going into the conventional database design. That's a very difficult thing to accommodate. So it's a highly specialized, high throughput system. But now imagine, I talked about synchronous phasers. I talked about cameras. I saw an article the other day where they were taking cameras and they were imputing vibration signals. And what a marvelous idea, because now without any contact at all, you're able to use existing knowledge on how vibration is indicating potential failure, but you're able to do it without physically connecting anything to a facility. But now think about the data. Think about the number of points you're bringing off those camera images. You're probably looking at visible spectrum, infrared spectrum, maybe ultraviolet spectrum, and all of it just come blowing in there. And then you got multiple cameras, and you can see it just keeps compounding. So I do believe that the more and the bigger the bite we take, the bigger the boundary. And I just don't see any stopping to that. But I'll tell you, there's also an incentive to do that. And I say this sometimes and it shocks people, but I've been doing this now for close to 50 years, 40 years at OSI, 7 years at Taylor, 3 years at Shell. That's 50 years. I have never seen a project where the value did not increase monotonically with scope. So if you think that there's not a driving force, imagine you have a scope of a single refinery, but now take that same amount of data and slightly less fidelity, but spread it over 100 refineries, or take that same amount of data and spread it around a country. And the potential value just asymptotically increases with scope. So if we can't handle the scope, then we have to build tools that'll do it. So when you talk about AI and machine learning, one of the real characteristics of those is that algorithmically handles this great influx of data without bothering everything else. We still have the basic functions we've always done, but now we can do a little bit more. We can look for problematic areas. We can look for things we've seen before. We can come out and impute what's happening through models, etc. So I see nothing but growth.
Well, that's encouraging to everybody out there. Maybe a good place to end this interview is you built a company for 40 years, and it's highly successful, as we've talked about in this interview. If you were to talk to the younger version of yourself, or somebody right now who's maybe 30 years old and thinking about starting a product-based company, what would be the one or two things you would tell them that you wish you had learned when you were that age, or you did and were the keys to your success?
I'd tell her to look at the customers. They'll tell you what to do. And if you do right by them, they'll lead you where you want to be. But that would be my biggest advice.
Well, that's great. I appreciate it. I've been wanting to do this interview for a while because I've always been so impressed by OSIsoft. We had to wait for the acquisition to get all finalized before we could do it. But Pat, thank you very much for coming on the podcast. And again, congratulations to you and the team.
Thank you for the time, and thank you for inviting me.